Hey, what's up everybody? It's Abdul here at Direct Tyres and Auto. In today's video, we're going to be looking at automotive batteries and the transition from lead acid into calcium. So today we're going to show you how we test the car battery in our shop, and also we'll show you how the charging system works and how that is also tested and what you need to look out for. So this battery here is your conventional lead acid battery. This consists of a composition of sulfate acid and water, distilled water. These are the maintenance type batteries which we had previously in the past. With the advance of technologies, now we've moved on to non-maintenance batteries, which is a real game changer where we stand today. So I'll quickly run you through what it used to be and what we've shifted on to. So this component here is your starter motor. This is what spins the flywheel when we engage the battery initially. This component, when we start the car, it is the highest drawing amperage for any component in the car, and it draws the most power when we start the car. So on initial startup, that's when you will be using the most power from the battery. That's why the CCA rating on the battery is extremely important. The CCA rating tells us or informs us cold cranking amps. So when the weather is really cold, how much power can this give out to turn this bad boy here? So this gear can turn the flywheel. Moving on, once the engine is all running, it's extremely important that the battery gets replenished, otherwise it's going to die out. Without the use of an alternator, the battery cannot be recharged, and so this component here is what keeps the battery running for you, and it does not die out, and you can go on really long drives without it going flat. So just to cover some of the laws and the science that we use and apply when we're testing electronics in your car, we'll show you the Vir Triangle and how these calculations are done. So all the electronics students will be familiar with the Vir Triangle here. I just want to quickly show you what they mean and how the different calculations can be done, and they still bring you to the same result. So the first one, the V, just let you know that stands for volts. Volts as for V. The I stands for amperes, amps. Right, and R stands for resistance. All these measurements are required for us to figure out how much electricity is flowing through any particular circuit. So I'll just quickly show you what this, how we can calculate these measurements. So volts can equal amps times resistance. That will give you the equation for volts. You'll be able to figure out how much volts is running through any electrical circuit. Amps can be calculated by doing volts divided by resistance. That will give you the amperes running through the circuit. Resistance can be measured by going volts divided by amps, and that will give you the resistance. Also, while we're on the topic of discussing science, we want to give a big shout out and a thank you to this man right here, who's born in the 1800s at some time. He's a Russian chemist. His name is Dmitry Mendeleev. This man, he stated in his biography that the periodic table was revealed to him in a dream. So we're going to throw that periodic table up for you right here so you can have a look. This is the man here. So because we're discussing batteries in today's video, it's important to understand the transition that we've come from and the evolvement of technologies. It's important to start at the beginning. So Dimitri and the periodic table, extremely important. Run through it. There you go. So this battery here is the older technology. It is the maintenance type battery. In this battery, we have the filler caps, which were used in the past to maintain the battery, because over time what would happen is the water would be consumed, the H2O particle in the battery would be consumed, and you would be left with a higher percentage of sulfuric acid. And so what you would have to do is remove the caps one by one and fill it to the right level with distilled water. That is now an obsolete kind of technology, as we've shifted and upgraded with all the advancements in time. Coming back to the battery, so after a period of time, you would have to top them up and keep checking them quite regularly to ensure that the battery would keep functioning. This one here we've actually changed out for a customer. He came in flat battery issue, and we've upgraded him to a non-maintenance battery. So over here we've got the calcium non-maintenance battery. This is the new upgraded version which the customer has been upgraded to. He no longer has to maintain his battery. These also come with a 2-year warranty when you purchase these with us. Coming back to the battery that was changed out, all the batteries that you have mostly in automotive consist of 12.6 volts. Now how that's produced is each of these batteries have 6 chambers. They're broken down into 6 chambers like this. And you have 6 chambers. They're also referred to as cells. Each cell in the battery produces 2.1 volts. If you calculate that all up, it will bring you to 12.6 volts. Now 12.6 volts is a fully charged automotive battery, and we count that as a good battery. So this one here was dead when we've changed it out, so that's all done for him. The insides of the batteries are still the same. So this one here, it still has 6 chambers or cells, but the chemical composition inside and the construction of the plates is now fully upgraded, quality components and no maintenance. So now we're out in the workshop. I'll quickly show you how to use the voltmeter, this guy right here, and how we test and measure the battery's voltage. I'll also show you the charging system and how the alternator is tested. So we'll go ahead and do that for you now. This one here, we'll shift it on to volts. Quickly right there, make sure it zeroes out. Hang on, I'll leave that right here for you. All right, 0, cool. That's what we want. So we want to ground it first. So touch the negative terminal and touch the positive terminal. If we come up to the voltmeter, that one is at 12.51, which is a relatively good battery. 12.6 is fully charged, so that's 12.1, and we count that as a good battery. Right, I'll show you how charging is tested. So what we'll do is we'll start the car and then we'll come back and we'll measure the voltage here. When the system is charging, we want to see between 13.6 and 14.6 maximum voltage. Any more than that, there'd be a problem with the voltage regulator in the alternator. So we'll just start the car. We'll see how the charging is. I'll go and crank the engine for you now. Start. So there you go, exactly as we wanted it. This one is charging up at 14.6 volts, 14.56 to be precise. That's exactly where we want it. So the charging system is functioning very well. The alternator is doing what it's supposed to do, and we've got 14.55 volts. I'll also show you how the alternator is tested. What we basically do, you've got a positive terminal on the alternator, this one right here. Just a moment. So we've removed the cover for the positive terminal, this one right here. I will crank the motor again for you, and then we'll test the voltage at the alternator. Just a sec. Please, you're in trouble. There it is. Okay. It's a bit of a touchy key, that one, but that's alright. So this one here, the way to test the voltage in the alternator, you got the positive terminal right there, and you can ground it anywhere on the alternator's casing, like that. And if we bring you back to the voltmeter there on the top, you can see we've got 14.57 volts, which is a awesome charging alternator. That's how you test the alternator's voltage. So that one is functioning really well. Alright, so there's one more tool that we have. It's a battery analyzer or a load tester. This one, pretty simple. You just hook it to the negative terminal and the positive terminal right there. Good connection. That's your battery analyzer. What we do here is we enter the cold cranking amps. On this car you've got a 450, so I'm going to go down just a little there. That's in. All you do then is hit the test button. Recharge, so it's good or recharge, 12.1 volts. I've tested this battery, so it's pretty good. I'm going to take the good on this one. What this does is it measures the cold cranking amps available at the battery. So I'm pretty sure we've all experienced a flat battery at some time, so it's really important to ensure you maintain and look after the health of your battery. You can come and get it tested with us. Other than that, I hope you enjoyed this and found some value. We'll catch you on the next one.